Hello, welcome to the Comet Update by Astronomy Center. I'm Blake Nancarrow.
And I'm Chris Vaughan.
We're going to talk to you tonight about this comet that is getting a lot of press. Everybody's very interested in C2020 F3 NEOWISE. This has suddenly appeared, this particular comet. Lots of people are trying to get pictures of it or observe it. So we want to help you out, explain sort of where it came from and how you might be able to see it or how you might be able to take a picture of it. It's really easy to see in binoculars right now, so that's cool. You might be able to see it just with your eyeballs. Anyway, we'll talk about that. We'll talk about websites and tools and a bit of sort of information where it is in the universe. I'm going to hand it over to Chris to give us some of the history and where it came from and so on.
Yeah, so when the solar system was created, a lot of the material floating around the solar system was ice and icy bodies. And when the sun ignited and started shining, a lot of the volatile icy material got cleaned out of the inner solar system and ended up collecting in a big spherical shell around our star called the Oort Cloud. And the Oort Cloud's about a light year and a half or maybe a little more distant from the inner solar system. And so it actually consists of millions or billions of small icy snowballs left over from the formation of the solar system. And because it extends so far sort of towards the next stars, occasionally as the stars in the galaxy jostle around, they gravitationally tug on each other, and a little gravitational pull can cause one or more of these icy snowballs, and they can be very big, many kilometers across, to lose its orbit and start falling into the sun and towards the inner solar system. And so when that happens, they get warmed up by the heat of the sun. The gases inside the comet begin to become released. The comet develops a bright glowing coma around its head. And then as the gas trails behind it, it also gets pushed away from from the sun. The solar wind from the sun pushes the gas away from the sun and produces a tail that follows the comet in the anti-solar direction, or the direction away from the sun. And so we have a number of space telescopes orbiting Earth. One of them's name is NEOWISE, and WISE is a wide field infrared survey telescope, and it's designed to take pictures of big swaths of space, of the sky, and look for things that are moving. And one of its prime objectives was to look for Kuiper belt objects, or these objects that are beyond the orbit of Neptune, and to find more and more of this population of minor bodies beyond the inner solar system, outside of the outer solar system, in fact. And way back in the end of March, this NEOWISE space telescope detected something moving that turned out to be a comet. And that comet was picked up later by another space telescope called the SOHO, which is the Solar Heliospheric Observatory, which its job is to stare at the sun all the time and watch for sun's eruptions that could, influence or negatively impact our GPS systems and our astronauts and things like that. And so we've got an image from the SOHO spacecraft in the view right now, and it gives you a spherical view with the centered on the sun. Now, normally the sun is too bright to look at, so the telescope's designed with a disk that blocks the glare of the sun and lets you see the stars and things around the sun. And down at the lower right, you can see, this is a set of about 6 or 7 days worth of images, and you can see that comet NEOWISE is sneaking across the bottom between June 22nd and June 27th. And using the data in this image and another observations, astronomers were able to determine the orbit of the comet and predict that it would swing by the sun on July 3rd or so, and then become visible, hopefully visible to observers on Earth, including amateur astronomers and sky watchers. Now we've been burned lately, so let me just bring in a view of the inner solar system here. So the reason that we're so excited is because in the last number of months, there have been a few comets that are predicted to become bright enough to see with the naked eye or with binoculars. And a number of them have actually fizzled out. And so what happens is that as the comets fall closer to the sun, they get warmed by the sun. Some of them get too close to the sun and they break up. And then they're no longer bright and as bright as they're predicted to be. And so fortunately for us, we've got one that's survived its trip past the sun. And what I've got here is a 3D model of the solar system. You can see we've got the sun in the middle, the orbits of the inner planets surrounding that out to Mars. And then this blue oval ellipse here is the orbit of Comet NEOWISE. Now, why is it called C2020 F3 NEOWISE? So the C refers to the fact that it's a comet. Some comets actually become captured by the sun's gravity and end up becoming a periodic visitor to the inner solar system. They shuttle in and out. For example, Comet Halley, which is the first periodic comet. So its code is P/1, and it actually orbits between about Venus and Saturn, and it comes back every 76 or so years. This comet, we're not sure if it'll end up being a periodic comet, so for now it's a C. And the /2020 means it was discovered in the year 2020. The F3 refers to the date of discovery. So what we do is we take the year and we divide it into 26 two-week periods starting in January, and we assign a letter of the alphabet. So the F would correspond to the second half of March, and the 3 would mean it's the third comet discovered in the second half of March. So we have latter March, the year 2020, third comet discovered. The NEOWISE comes from the name of the discovering entity. In this case, it's a robotic spacecraft. But we have other robotic systems. Pan-STARRS is another one. Sometimes an individual gets to discover it and they get their name assigned to the comet. So Terry Lovejoy, who lives in Australia, he's discovered a number of comets. We have David Levy, a noted Canadian astronomer, has discovered a number of comets. So if it sounds like a person's name, it probably was. If it sounds like an unusual name, it's probably an acronym for a space telescope or a robotic camera system. So here we have the comet. We can see that back on, this is today's date. If I wind back to around the 3rd of July, you can see that the comet swung by the sun. I'm just going to zoom in a little bit here. So it passed just outside the orbit of Mercury, the red orbit here. And that would have been its closest approach to the sun and its maximum heating. And of course, the tail is always going to point away from the comet as it moves around. And so it survived the passage. And as we advance the dates, you can see that it's swinging up from the southern half or below the plane of the solar system into the northern plane, north of the plane of the solar system. Now, the Oort cloud being a sphere means that the comets can come in from any direction. They don't come in at the plane of the rest of the classical planets. So this comet actually came in from below, swung around the sun, and it's now headed into the north half of the solar system. And from here, we're not quite sure. At the moment, we have an elliptical sort of orbit for it. But as it passes the various planets on its way, they can perturb its orbit slightly. So we're not quite sure what the final orbit will be. But the cool news is that in the next couple of weeks, the comet's trajectory is going to bring it closest to the Earth around the 23rd of July. So around the 23rd of July, it'll reach what we call perigee, or closest to the Earth. And that will theoretically make it brighter because it's nearer to us. But at the same time as it's departing the sun's warmth, it's not being, the outgassing will reduce. So there's sort of a balancing act between its nearness to us and how bright it is from the amount of gas it's giving off. But we're really optimistic. It's already survived its passage of the sun. It didn't break up. It didn't get sucked into the sun and lost forever. And so it's kind of thing that we're going to be able to see from Earth. So Blake, I'm going to send it back to you to talk about that.
Hey, Chris, it looks like when it was pretty close to the sun or a couple of days before, it looks like the best seats were at Mercury. It's too bad we couldn't be there to watch it.
Contact Mercury base and have them send the pictures.
And you use the word perigee when it's close to the Earth. What's the word scientists use for when it's close to the sun?
That's perihelion, for the Greek word helios, meaning the sun.
Okay, great.
All right.
All right, thanks. What I'm going to show to you now is the view from home, from Earth base. And specifically, this is a snapshot from some software that I used to simulate the sky chart or view for the Toronto area at 4:30 in the morning. Now, this should work for people in Ontario, Manitoba, Quebec. The view is basically going to be the same. It's going to be a bit different, the timing and the location in the sky a little bit for people that are out west and on the east coast and so on. So this is a really good simulation of what we can see in Ontario and points nearby. You can see these kind of cyan color, blue colored markers. They look a little bit like a lollipop with a stick sticking out of it here. And it starts over on the 5th. That was the comet's location early in July. Here's the 8th. That's where it was located this morning. Again, this is 4:30 in the morning each of these days. There's the location tomorrow. And you can see it's moving along to the west. So the constellation Auriga is a good marker for where the comet is now for the next couple of days. And then it's moving off to the left into the constellation Lynx. Now, Auriga is great because it's got some really bright stars in here, like Capella and the Theta star down at the bottom. But Lynx doesn't have really bright stars, so it's going to be a little bit trickier there, maybe to use some markers to spot it. The big orange circle that I have here, that's the view that you would see with regular binoculars. I was using my 7 times power binoculars to view the comet. So that hopefully that will help you sort of frame things and so on. But again, using some bright stars can help get you into the zone, into a good spot here. Again, the view and the passage in the sky, it'll be affected by your location. So if you're at the extreme west coast of Canada or east coast or the far north, the times when you can best view this comet will be a bit different. Chris is going to talk about that momentarily. In terms of how to view a comet, sort of what you might use, it's pretty simple stuff. You need some eyeballs. If you've got some binoculars, they don't have to be special. I used my very inexpensive old binoculars, and it was a great view actually. In the binoculars, could see the core of the comet, the tail very easily. It's quite nice. If your binoculars can be mounted on a tripod, that's a great thing to do. It gives a nice steady view. But if you don't have a tripod, you don't have binoculars with a tripod mount, you can do tricks like lean up against something, a building, or sit in such a way that you can prop up the binoculars and keep them steady. As much as you can, try to get a steady view in your binoculars. And if you just sweep around, you should be able to see the comet. That's I forgot to mention it before, but that's going to be in the northeast direction. That's where you'll find Auriga before sunrise. If you want to take a picture of this with your camera, it's pretty easy to do actually. Now you definitely want your camera on a tripod to get things steady, and I've got a few other suggested items that you might need there. Here's some settings that you might use for your camera. I started off with a 30-second exposure. The comet was really obvious. I used ISO 1000, f8 on the lens. I didn't have my white balance set correctly at the beginning, but I was able to change it later. Focusing is a little tricky. Sometimes camera lenses, when auto-focusing, won't be able to work on the sky. But if you do some tricks, maybe aim to Venus. Venus is really close to the comet. It's just off to the right side of Auriga. You can use Venus to focus, or a star, bright star, again, Capella, to focus. That might work nicely. I focused on a star and then I switched the lens to manual so it wouldn't try to change focus after that. And here's another little trick to make the camera be steady. Use the self-timer feature. Set it to a 2-second or a 10-second self-timing mode, or use a remote release. And then the camera will be steady as it starts to do its exposure. And if you're shooting long exposures, like 30 seconds and high ISO, you can get noise in the camera. So a quick trick is turn on the noise reduction feature or do dark subtraction, and you'll get a nice clean image when you do that. So those are a few tips with a view sort of focused on Ontario. I'm going to hand it back to Chris to show us how the sky will look if we're in different locations across Canada.
So this is the sky using a software package called Stellarium. You can see the name is in the upper corner here. It's stellarium.org. We love this in astronomy and outreach and all the rascals. Love the software because it's free, it's open source, you can put it on a Mac or a PC. You can even find versions that run on your smartphone or your tablet. And so I use this a lot for my planning and for my, reviewing what's coming up in the sky. And we can use this to talk about, what's the comet going to do for different locations in the country. And one of the things I wanted to just reinforce from what Blake was saying is in order to find the comet, so I've got the comet's location pinned down here, you can see that. And a good rule of thumb, this is going to be for tomorrow morning, let's go to tomorrow morning on the 9th. And what you can do is use Capella or Theta, but from Capella, you can actually use your fist. If you make a fist and hold it at arm's length and close one eye, you want to measure about 1.5 fists diameter just down and a bit to the right or a bit to the left of Capella. And that should put you in the ballpark of where the comet is. While you're up, make sure you take a look at Venus. Venus is over here. As Blake mentioned, you can use it as your focusing tool. But Venus is actually bopping its way through the face of Taurus the bull right now. So this is the orange stick that I've got labeled here is showing the path or the trajectory of the comet. I've got time and date setting tools here, so I can advance the date day by day by day. You can see how the comet journeys across the sky. This is for Toronto. And because the comet is moving north, when I showed you that 3D model of the comet coming up from below the solar system and heading to the north, that means it was moving away from the sun from our point of view and heading north. You can see here's the Big Dipper and Polaris is up here. And as objects get into this patch of the sky, they become circumpolar, which means they never set. And so you can see that the information for the comet up here in the top corner says it's circumpolar, it never sets. And that means that actually you can view the comet before dawn, around 4:30, or you can run in late evening and catch it after dusk. So here's about 10:30 p.m. So here's 9:30 p.m., 10:30 p.m., 11:30 p.m. in the north, sort of northwestern sky. So you've got your two options there. Next week, that's not till about next week. If we go back to now and head into the morning sky again, then it's basically a morning object. Now, if you live out on the East Coast, your view of the comet compared to Capella won't vary from where you are in Canada, but your view of the comet with respect to the horizon will vary a lot depending on your latitude and your location in the country. So if you head out and show the sky in Halifax, you can see that there's the Halifax sky at 4:30. It's getting a little bright, so probably 4 a.m. is better for you. And again, you can advance it into the future. It's going to stay a little bit lower, so perhaps it's not going to be quite so good in the evening. There's the evening sky, so that's not a bad elevation. That's 10 degrees above the horizon. Again, that's a fist diameter held at arm's length at 11 p.m. around mid-month. And as we head later in the month, it's going to be getting higher and higher and higher. So it's going to be easier to see because it's higher, but it's also going to be fading in brightness. And Blake's going to show you some brightness charts in a little while to sort of demo that. We'll just go back to 4 o'clock. So that's your view in Halifax, or we can head out to Vancouver. Here, oh, wrong way around. I need to go to 4 in the morning. There we go. So here's Vancouver about 4 in the morning. Again, 4 in the morning is a bit too late. The sky's getting a bit bright, so you're really needing to be up more like 3:30 or so. And that's the comet's path, again, heading north towards the Big Dipper over the next number of nights for the next couple of weeks. And if you're in the far north of Canada, say Yellowknife, you're going to be out of luck because unfortunately your sky never gets dark. So even though the comet is circumpolar, the sky never quite gets dark enough for you to see it. So it's really going to be a treat more for the folks that live in the southern portion of the country. I'll just head back to Ontario here. There you go. And I go back to the 9th.
Okay.
Back to Blake.
Thanks, Chris. So thanks, Chris, for showing us where the comet is in the sky for different locations. We've got a few photos that have been captured by members of RASC. So I just wanted to run a little movie and show these, and Chris is going to talk about these as we go through this. There we go. I'll pause it at a couple of stages.
This is a zoomed in photo taken by Jeff Booth, a Toronto Centre member. He took this from the Niagara Escarpment, sort of above Stony Creek on the 6th of July. You can see that he composed it nicely with a cityscape below it. And there's the whole photo. But I think he said he had about a half an hour window between the time it got high enough and then the time the sky was getting bright.
Back up there.
So Blake, I think you said that this view was comparable to what you saw in your binoculars, right? Is that right?
Yeah, these zoomed in images are great, and it did feel like I was seeing the same kind of view in my binoculars. Really bright starlight core for the comet. The tail was obvious. The tail was vertical, going up in the sky, fan-shaped. So these zoomed in pictures are pretty well exactly what I saw in the binoculars. That was great. That one was
this photo by Raymond is taken from close to the city, I believe. And this one by Patrick McDonald would have been within the city as well. The great thing about this photo was that the exposure time that he allowed to capture the comet allowed him to capture a segment of the flight of the International Space Station at the same time. So that stripe, is the travel of the International Space Station over the horizon with the comet.
That's a great photo, and that reminds me of when I was taking a photograph of the comet. It didn't show up in my photos, but a really bright meteor went overhead. It was coming from the south, it went to the north. I think it was an asteroid, and it left a little sparkly trail behind it. So that was like a freebie. It made it worth getting up so early in the morning. Chris, you showed us some views with Stellarium and Starry Night Pro. Would you like to share some information about apps that people can use on their mobile devices?
Sure. So this is demoing an app called SkySafari 6. So SkySafari 6 is kind of the gold standard for people who are getting into serious astronomy, although it's great for beginners all the way up to seasoned veterans. It comes in 3 price points. There's a basic version, which I think is free or close to free. There's a plus version, which is a small amount of money, and then there's a pro version. And the higher up in level you go, the deeper the catalogs, the more objects that are in it, the more features that you have in it as well. And what's great about this is that you can put this on your phone or your tablet and take it out for your comet hunting and use it to find the object. So for example, you can see that there's a button down at the bottom toolbar there called compass. You can actually press that and then hold it up to the sky and run your tablet around. And I'm indoors, so I'm not really getting the full benefit of that, but you can actually use that to put it up to the sky. And you can even use the search button to look for the brightest comets, put NEOWISE and center it. And I believe if I use the compass, it might even direct me to where it is, but you can use that to find or confirm the position of the comet. Now, if you're going to use this app, the best thing to do is to make sure that the data inside the app is up to date, because as I said before, the comet's orbit actually varies slightly as it encounters the various objects in the inner solar system. So they do update the orbits of the objects so that you can have a very accurate position information. And the way you can do that in SkySafari, if you're using the Plus or Pro versions, is to go into Settings, click on Solar System on the left column there, and then scroll on the right to the bottom of the page. You'll see that there's a button or a hyperlink called Update Minor Body Orbit Data. And if you click on that, I've done it a little while ago. I'm not going to do it again. It'll take, depending on your internet connection, it could take a couple of minutes, a few minutes, to go off to the web and collect all the latest data on all the various objects that are in the app. So all the comets, all the asteroids, including Comet NEOWISE. So once you've done that, then you can be confident that the app is showing you the correct location. And you can sit here and change the date just like I could in Stellarium, and use it for lots as well. You can zoom in and do a number of things. So SkySafari is a great app to use or look at. There's another one called Starwalk 2, which I've checked, and it does have Comet NEOWISE information in there as well. And so those are a couple that I highly recommend.
All right, thanks, Chris, for that update on apps. There's lots of software out there and lots of apps, but these are ones that we regularly use and like. I also wanted to talk to you about some websites that are sort of official or really good sources of information for comets. Errorith.net, a lot of us use. This is by Seiichi Yoshida. It's a really good comet website. Comet Chasing at the Skyhound website. This is by Greg Krinklaw. He's the author of the SkyTool software that I use a lot. And there's a new one that I've heard about, the Comet Observation Database, or COBS. So maybe I can quickly show you these, what they look like, so we see what's going on. So here's the, let me back up to the home page. So here's Mr. Yoshida's website. So you have to scroll down a little bit from the top of his homepage, and you'll see the weekly information about bright comets. So he keeps it very up to date, and you get a list now of various comets that are interesting. There's usually an image, brief description. He indicates whether it's visible in the northern or the southern hemisphere. He'll talk about the brightness value measured in magnitudes. The most recent sort of report of that gives a brief assessment as to how observable it will be for people in different locations. When you click on a particular comet page, you start getting more information. Here, again, a photo, orbital element data. Now, I like these finding charts because it gives you a good sense of where the comet is on a day-by-day basis. Gives you a sense of the speed, how rapidly it's moving through the sky. So you can see that we're up here near the top right-hand corner. You can see there's July 9th. So that's how where the comet will be placed tomorrow morning. And it's kind of squished. It's a distorted view of the sky, but there's the Auriga constellation that we were talking about before. And again, you can see it's moving to the left in this image in a big arc, moving through Lynx and Ursa Major, and ending up in August in Coma Berenices. So again, as Chris pointed out, it's climbing into the night sky and climbing higher into the sky, but depending on your location, that may or may not be easy. And we don't quite know what's going to happen with the brightness of this. Another nice thing about this website is the plot of the magnitude or the brightness of the comet. So this is really nice. If you're on the upswing, there's usually lots of excitement. You can see that, this is basically today, and it looks like we're at the peak. So that means the time is nigh. You got to look for this now. You got to try to see this comet or image or view this comet as soon as you can.
It fades quite precipitously.
Yeah. So if it's clear tomorrow, set your alarm. You gotta do this. So this is a great website. Lots of really useful information here. Here's the cometchasing.skyhound.com website at the Skyhound company. And again, brief synopsis up at the top of various comets, the quick assessment of their visibility and what the predicted magnitudes will be. Some images you can see there of a comet that recently broke up. We were excited about that one, but it broke up. But here's now some detailed information about C2020 F3 NEOWISE. And I like these little quick headings where it says it's visible in binoculars. So that tells you kind of the gear that you're going to need, or visible on a small telescope. And you can see it's broken down by latitudes, and we've got weekly columns here with a brief assessment. So that can help you, again, know whether it's going to be visible in the morning or the evening and how easy it's going to be and so on. And there's finder charts that you can pull up with that. And I mentioned the COBS website. This one's new to me, so I don't have a lot of experience with this, but it looks like to me they are advocating citizen science. It looks like members can submit their observations. So you could do reporting here. You can see there's another plot or a graph, and it looks like we're at the peak. So looks like lots of good information here. I've yet to sort of really explore this site. There's an image, different comet, mind you. So lots of good websites that you can use or that you can consult to get more information about comets.
And Blake, those predicted brightness graphs are just guesses, right? I mean, comets can do an outburst where they suddenly pick up in brightness unexpectedly.
Bet.
We just don't know.
Really good point. The everything to the left of that vertical line, that's the path, so that's sort of known data. But they're mathematically computing the rest of the curve, so it could change. And comets, was it David Levy that said comets are like cats? They have tails and they do whatever they want. So we don't know exactly what will happen in the future with their brightness. Okay, some closing comments here. Chris and I thank you for your time. We hope that we've been able to help you out with learning about this particular comet or comets in general. If you have more questions, don't hesitate to reach out to us. We've got our email addresses there, although we modified them a little bit, so you'll need to substitute in the appropriate characters. Chris, on a weekly basis, updates his Astronomy Skylights e-newsletter. That's at astrogeo.ca, so check that out. And I do periodic random sort of updates on my blog.lumpydarkness.com, and you'll see the photos that I took a couple of days ago of the comet if you check that out. Any closing comments, Chris?
Yeah, so I plot, or I post a weekly sky chart showing the path of the comet every week, so you can see what it's doing each particular week. We also invite you to keep your eye on skynews.ca. We also post some up-to-date information on skynews.ca as well. But yes, check the weather, then set the alarm.
All right. Thanks, everybody.
Thanks. Keep looking up.